The following is a conversation with Lisa Feldman Barrett, a professor of psychology at Northeastern University and one of the most brilliant and bold thinkers and scientists I've ever had the pleasure of speaking with. She's the author of a book that revolutionized our understanding of emotion in the brain called How Emotions Are Made, and she's coming out with a new book called 7.5 Lessons About the Brain that you can and should pre-order now. I got a chance to read it already, and it's one of the best short whirlwind introductions to the human brain I've ever read. It comes out on November 17th, but again, if there's anybody worth supporting, it's Lisa, so please do pre-order the book now. Lisa and I agreed to speak once again around the time of the book release, especially because we felt that this first conversation is good to release now, since we talk about the divisive time we're living through in the United States leading up to the election. And she gives me a whole new way to think about it from a neuroscience perspective that is ultimately inspiring of empathy, compassion, and love. Quick mention of each sponsor, followed by some thoughts related to this episode. First sponsor is Athletic Greens, the all-in-one drink that I start every day with to cover all my nutritional bases that I don't otherwise get through my diet naturally. Second is Magic Spoon, low-carb, keto-friendly, delicious cereal that I reward myself with after a productive day. The cocoa flavor is my favorite. Third sponsor is Cash App, the app I use to send money to friends for food, drinks, and unfortunately for the many bets I have lost to them. Please check out these sponsors in the description to get a discount and to support this podcast. As a side note, let me say that the bold, first principles way that Lisa approaches her study of the brain is something that has inspired me ever since I learned about her work. And in fact, I invited her to speak at the AGI series I organized at MIT several years ago. But as a little twist, instead of a lecture, we did a conversation in front of the class. I think that was one of the early moments that led me to start this very podcast. It was scary and gratifying, which is exactly what life is all about. And it's kind of funny how life turns on little moments like these that at the time don't seem to be anything out of the ordinary. If you enjoy this thing, subscribe on YouTube, review it with 5 stars on Apple Podcasts, follow on Spotify, support on Patreon, or connect with me on Twitter at Lex Friedman. As usual, I'll do a few minutes of ads now and no ads in the middle. I try to make these interesting, but I give you timestamps, so if you skip, please still check out the sponsors by clicking the links in the description. It's the best way to support this podcast. This show is brought to you by Athletic Greens, the all-in-one daily drink to support better health and peak performance. Even with a balanced diet, it's difficult to cover all your nutritional bases. That's where Athletic Greens will help. Their daily drink is like nutritional insurance for your body that's delivered straight to your door. I fast often, sometimes intermittent fasting of 16 hours, sometimes 24 hours, dinner to dinner. I'm actually considering doing a 48 and a 72-hour fast as well. I break the fast with Athletic Greens. It's delicious, refreshing, just makes me feel good. I think it's like 50 calories, less than a gram of sugar, but has a ton of nutrients to make sure my body has what it needs despite what I'm eating. Go to athleticgreens.com/Lex to claim a special offer of free vitamin D3K2 for a year. So click athleticgreens.com/Lex in the description to get the free stuff and to support this podcast. This episode is also sponsored by Magic Spoon, low-carb, keto-friendly cereal. I've been on a mix of keto and carnivore diet for a long time now. That means eating very few carbs. I used to love cereal. Obviously, most cereals have crazy amounts of sugar, which is terrible for you. So I quit years ago. But Magic Spoon is a totally new thing. 0 sugar, 11 grams of protein, and only 3 net grams of carbs. I personally like to celebrate accomplishments and productivity with a snack of Magic Spoon. It feels like a cheat meal, but it's not. It tastes delicious. It has 4 flavors: cocoa, fruity, frosted, and blueberry. And I think they come out with some new ones. I tried all of them. They're all delicious. But if you know what's good for you, you'll go with cocoa, my favorite flavor and the flavor of champions. Click the magicspoon.com/Lex link in the description and use code LEX at checkout for free shipping. This show is presented by Cash App, the #1 finance app in the App Store. When you get it, use code LEX Podcast. Cash App lets you send money to friends, buy Bitcoin, and invest in the stock market with as little as $1. Let me put a new idea out there. I'll send $42 to anyone via the Cash App who makes a meme or podcast mashup video making fun of me, since my ego needs to be brought down a notch. Or even if you create some cool art, music, or a thing of any kind related to this podcast that either makes me LOL in real life or is just awesome, beautiful, inspiring in some way. Post it in the Lex Friedman subreddit and include your cash tag if you want to be in the running for the many $42 awards that I'll give. It's not about the money. As always, it's about the love. So again, if you get Cash App from the App Store or Google Play, use code LEX Podcast. You get $10, and Cash App will also donate $10 to FIRST, an organization that is helping to advance robotics and STEM education for young people around the world. And now, here's my conversation with Lisa Feldman Barrett. Since we'll talk a lot about the brain today, do you think, let's ask the craziest question, do you think there's other intelligent life out there in the universe?
Honestly, I've been asking myself lately if there's intelligent life on this planet. I have to think probabilities suggest yes. And also secretly, I think I just hope that's true. It would be really, I know scientists aren't supposed to have hopes and dreams, but I think it would be really cool. And I also think it would be really sad if it wasn't the case. If we really were alone, that would seem profoundly sad, I think.
So it's exciting to you, not scary?
Yeah, no, I take a lot of comfort in curiosity. It's a great resource for dealing with stress. So I'm learning all about mushrooms and octopuses and, all kinds of stuff. And so for me, this counts, I think, in the realm of awe. But also, I think I'm somebody who cultivates awe deliberately on purpose to feel like a speck. I find it a relief occasionally.
To feel small.
To feel small in a profoundly large and interesting universe.
So maybe to dig more technically on the question of intelligence, do you think it's difficult for intelligent life to arise like it did on Earth? From everything you've written and studied about the brain, how magical of a thing is it in terms of the odds it takes to arise?
Yeah, so, magic is just... Don't get me wrong. I mean, I like a magic show as much as the next person.
Yeah.
My husband was a magician at one time, but magic is just a bunch of stuff that we don't really understand how it works yet. So I would say, from what I understand, there are some major steps in the course of evolution that, at the beginning of life, the step from single cell to multicellular organisms, things like that, which are really not known. I think for me, the question is not so much, could it, what's the likelihood that it would happen again, as much as what are the steps and how long would it take? And if it were to happen again on Earth, would we end up with the same, menu of life forms that we currently have now? And I think the answer is probably no, right? There's just so much about evolution that is stochastic and driven by chance.
But the question is whether that menu would be equally delicious, meaning like there'd be rich complexity of the kind of, like, would we get dolphins and humans or whoever else falls in that category of weirdly intelligent, seemingly intelligent, however we define that?
Well, I think that has to be true if you just look at the range of creatures who've gone extinct. I mean,
Right.
if you look at the range of creatures that are on the earth now, it's incredible. And, it's sort of trite to say that, but it actually is really incredible. Particularly, I don't know, I mean, there are animals that seem really ordinary until you watch them closely and then they become miraculous, like certain types of birds, which do very miraculous things, uh, build, bowers and do dances and all these really funky things that are hard to explain with a standard evolutionary story, although,
Yeah,
people have
the
them.
birds are weird. They do a lot for mating purposes. They have a concept of beauty that I
Well,
haven't quite. Maybe you know much better, but it doesn't seem to fit evolutionary arguments
it
well.
does fit. It
But,
depends, right? So I think you're talking about The Evolution of Beauty, the book that was written recently by, was it was that his name? Richard Fromm, I think, at
oh,
Yale.
interesting. No, I didn't.
Oh, it's a great book. It's very controversial, though, because he's making the argument that the question about birds and some other animals is why would they engage in such metabolically costly displays when it doesn't improve their fitness at all? And the answer that he gives is the answer that Darwin gave, which is sexual selection. Not natural selection, but selection can occur for all kinds of reasons. There could be artificial selection, which is when we breed animals, right? Which is actually how Darwin that observation helped Darwin come to the idea of natural selection.
Oh, interesting.
And then there's sexual selection, meaning, and the argument that I think his name is Fromm makes is that it's the pleasure. The selection pressure is the pleasure of female birds, which as a woman and as someone who studies affect, that's a great answer. I actually think there probably is I think there is an aspect of natural selection to it, which he maybe hasn't considered.
But you were saying the reason we brought up birds is the life we got now seems to be quite
Yeah,
incredible.
so you peek into the ocean, peek into the
Yeah.
sky. There are miraculous creatures. Look at creatures who've gone extinct. And, in science fiction stories, you couldn't dream up something as interesting. So my guess is that, intelligent life evolves in many different ways, even on this planet. There isn't one form of intelligence. There's not one brain that gives you intelligence. There are lots of different brain structures that can give you intelligence. So my guess is that the menagerie might not look exactly the way that it looks now, but it would certainly be as interesting.
But if we look at the human brain versus the brains, or whatever you call them, the mechanisms of intelligence in our ancestors, even early ancestors, that you write about, for example, in your new book, what's the difference between the fanciest brain we got, which is the human brain, and the ancestor brains that it came from?
Yeah, I think it depends on how far back you want to go.
You go all the way back, right, in
Well,
in your book. But, so, what's the interesting comparison? Would you say?
Well, first of all, I wouldn't say that the human brain is the fanciest brain we've got. I mean, an octopus brain is pretty different and pretty fancy, and they can do some pretty amazing things that we cannot do. We can't grow back limbs. We can't change color and texture. We can't comport ourselves and squeeze ourselves into a little crevice. I mean, these are things that we invent. These are like superhero abilities that we invent in stories, right? We can't do any of those things. And so the human brain is certainly, we can certainly do some things that other animals can't do that seem pretty impressive to us. But I would say that there are a number of animal brains which seem pretty impressive to me, that can do interesting things and really impressive things that we can't do.
I mean, with your work on how emotions are made and so on, you kind of repaint the view of the brain as less glamorous, I suppose, than we
Well,
would otherwise think.
no.
Or like, I guess you draw a thread that connects all brains together in terms of homeostasis and all that kind of stuff.
I wouldn't say that the human brain is any less miraculous than anybody else would say. I just think that there are other brain structures which are also miraculous. And I also think that there are a number of things about the human brain which we share with other vertebrates, other animals with backbones, but that we share these miraculous things. But we can do some things in abundance, and we can also do some things with our brains together, working together, that other animals can't do, or at least we haven't discovered their ability to do it.
Yeah, this social thing. That's one of the things you write about. How do you make sense of the fact, like the book Sapiens, and the fact that we're able to kind of connect, like network our brains together, like you write about. I'll try to stop saying that. uh, is that like some kind of feature that's built into there? Is that unique to our human brains? Like, how do you make sense of that?
What I would say is that our ability to coordinate with each other is not unique to humans. There are lots of animals who can do that, and we. But what we do with that coordination is unique because of some of the structural features in our brains, and it's not that other animals don't have those structural features. It's we have them in abundance.
Mm.
So, the human brain is not larger than you would expect it to be for a primate of our size. If you took a chimpanzee and you grew it to the size of a human, that chimpanzee would have a brain that was the size of a human brain. So there's nothing special about our brain in terms of its size. There's nothing special about our brain in terms of the basic blueprint that builds our brain from an embryo is the basic blueprint that builds all mammalian brains and maybe even all vertebrate brains. It's just that because of its size, and particularly because of the size of the cerebral cortex, which is a part that people mistakenly attribute to rationality.
Why mistakenly? Isn't that where all the clever stuff happens?
Well, no, it really isn't. And I will also say that lots of clever stuff happens in animals who don't have a cerebral cortex. But
right.
But because of the size of the cerebral cortex and because of some of the features that are enhanced by that size, that gives us the capacity to do things like build civilizations and coordinate with each other, not just to manipulate the physical world, but to add to it in very profound ways. Like, other animals can cooperate with each other and use tools. We draw a line in the sand and we make countries, and then we create, we create citizens and immigrants.
But also ideas. I mean, countries are centered around the concept of like ideas.
What do you think a citizen is and an immigrant? Those are ideas.
Right.
Those are ideas that we impose on reality and make them real. And then they have very, very serious and real effects, physical effects on people.
What do you think about the idea that a bunch of people have written about, Dawkins with memes, which is like ideas are breeding, like we're just like the canvas for ideas to breed in our brains. So this kind of network that you talk about of brains is just a little canvas for ideas to then compete against each other and so on.
I think as a rhetorical tool, it's cool to think that way. So I think it was Michael Pollan. I don't remember if it was in The Botany of Desire, but it was in one of his early books on botany and gardening, where he wrote about plants sort of utilizing humans for their own evolutionary purposes, which is kind of interesting. You can think about a human gut in a sense as a propagation device for the seeds of tomatoes and what have you. So it's kind of cool. So I think rhetorically it's an interesting device, but ideas are, as far as I know, invented by humans, propagated by humans. So I don't think they're separate from human brains in any way. Although it is interesting to think about it that way.
Well, of course, the ideas that are using your brain to communicate and write excellent books, and they basically picked you, uh, Lisa, as an effective communicator, and thereby are winning. So that's an interesting worldview. To think that there's particular aspects of your brain that are conducive to certain sets of ideas, and maybe those ideas will win out.
Yeah, I think the way that I would say it really, though, is that there are many species of animals that influence each other's nervous systems, that regulate each other's nervous systems. And they mainly do it by physical means. They do it by chemicals, scent. They do it by, so termites and ants and bees, for example, use chemical scents. Mammals like rodents use scent, and they also use hearing, audition, and that little bit of vision. Primates, non-human primates add vision, right? And I think everybody uses touch. Humans, as far as I know, are the only species that use ideas and words to regulate each other, right? I can text something to someone halfway around the world.
That's fascinating.
They don't have to hear my voice. Yeah. They don't have to see my face, and I can have an effect on their nervous system. And the ideas that we communicate with words, I mean, words are, in a sense, a way for us to do mental telepathy with each other, right? I mean, I'm not the first person to say that, obviously, but how do I control your heart rate? How do I control your breathing? How do I control your actions with words? It's because those words are communicating ideas.
So you also write, I think, let's go back to the brain. You write that Plato gave us the idea that the human brain has three brains in it, three forces, which is kind of a compelling notion. You disagree. First of all, what are the three parts of the brain, and why do you disagree?
So Plato's description of the psyche, which for the moment we'll just assume is the same as a mind. There are some scholars who would say, a soul, a psyche, a mind, those aren't actually all the same thing in ancient Greece, but we'll just for now gloss over that. So Plato's idea was that, and it was a description of really about moral behavior and moral responsibility in humans. So the idea was that, the human psyche can be described with an metaphor of two horses and a charioteer. So one horse for instincts, like feeding and fighting and fleeing and reproduction. I'm trying to control my salty language, which apparently they print in England. Like I actually tossed off a fairly...
Which F, S?
Yeah,
Which
F,
one?
F.
Okay.
F, yeah.
Yeah.
I was like, you printed that. I couldn't believe you printed that.
Without like the stars or whatever?
No. There was full print.
Okay,
yeah. They
great.
also printed a B word, and it was really yeah.
Well,
Anyways.
we should learn something from England.
Indeed. Anyways, but instincts. And then the other horse represents emotions. And then the charioteer represents rationality, which controls, the two beasts, right? And fast forward, couple of centuries, and in the middle of the 20th century, there was a very popular view of brain evolution, which suggested that you have this reptilian core, like a lizard, an inner lizard brain for instincts, and then wrapped around that layer on top of that evolved a limbic system for in mammals. So the novelty was in a mammalian brain, which bestowed mammals with, gave them emotions, the capacity for emotions. And then on top of that evolved a cerebral cortex, which in largely in primates, but very large in humans. And it's not that I personally disagree. It's that as far back as the 1960s, but really by the 1970s, it was shown pretty clearly with evidence from molecular genetics, so peering into cells in the brain to look at the molecular makeup of genes, that the brain did not evolve that way. And the irony is that, the idea of the three-layered brain with an inner lizard, that hijacks your behavior and causes you to do and say things that you would otherwise not, or maybe that you will regret later. That idea became very popular, was popularized by Carl Sagan in The Dragons of Eden, which won a Pulitzer Prize in 1977, when it was already known pretty much in evolutionary neuroscience that the whole narrative was a myth.
So, well, the narrative is on the way it evolved, but again, it's that problem of it being a useful tool of conversation to say, like, there's a lizard brain and there's like, if I get overly emotional on Twitter, that was the lizard brain and so on. But do you...
No, I don't think it's useful. I think that...
But is it useful? Is it accurate?
I don't think it's accurate, and therefore I don't think it's useful.
Got it.
So here's what I would say. I think that the way I think about philosophy and science is that they are useful tools for living. And in order to be useful tools for living, they have to help you make good decisions. The triune brain, as it's called, this three-layer brain, the idea that your brain is like an already baked cake, and the cortex, cerebral cortex, just layered on top like icing. Mm-hmm. That idea is the foundation of the law in most Western countries. It's the foundation of economic theory, and it's a great narrative. It sort of fits our intuitions about how we work. But it also, it's, in addition to being wrong, it lets people off the hook for nasty behavior, and it also suggests that emotions can't be a source of wisdom, which they often are. In fact, you would not want to be around someone who didn't have emotions. That's a psychopath.
Right.
I mean, that's not someone you want to really have that person deciding your outcome. So I guess and I could sort of go on and on and on, but my point is that I don't think it's a useful narrative in the end.
What's the more accurate view of the brain that we should use when we're thinking about it?
I'll answer that in a second, but I'll say that even our notion of what an instinct is or what a reflex is not quite right? So if you look at evidence from ecology, for example, and you look at animals in their ecological context, what you can see is that even things which are reflexes are very context sensitive. The brains of those animals are executing so-called instinctual actions in a very, very context-sensitive way. And so, even when a physician, takes it's like the idea of your patellar reflex where they hit, your patellar tendon on your knee and you kick. The force with which you kick and so on is influenced by all kinds of things. It's a reflex isn't like a robotic response. And so I think a better way is a way that to think about how brains work is the way that matches our best understanding, our best scientific understanding, which I think is really cool because it's really counterintuitive. So how I came to this view, and I'm certainly not the only one who holds this view. I was reading work on neuroanatomy, and the view that I'm about to tell you was strongly suggested by that. And then I was reading work in signal processing, like by electrical engineering. And similarly, the work suggested that the research suggested that the brain worked this way. And I'll just say that I was reading across multiple literatures, and who don't speak to each other. And they were all pointing in this direction. And so far, although some of the details are still up for grabs, the general gist, I think, is I've not come across anything yet which really violates, and I'm looking. And so the idea is something like this. It's very counterintuitive. So the way to describe it is to say that your brain doesn't react to things in the world. It's not, to us, it feels like our eyes are windows on the world. We see things, we hear things, we react to them. In psychology, we call this stimulus response. So your your voice is a stimulus to me. I receive input and then I react to it. And I might react very automatically, system one. But I also might execute some control where I maybe stop myself from saying something or doing something, and in a more reflective way, execute a different action, right? That's system two. The way the brain works, though, is it's predicting all the time. It's constantly talking to itself, constantly talking to your body, and it's constantly predicting what's going on in the body and what's going on in the world, and making predictions. And the information from your body and from the world really confirm or correct those predictions.
So fundamentally, the thing that the brain does most of the time is just like talking to itself and predicting stuff about the world, not like this dumb thing that just senses and responds.
So the way to think about it is like this. Your brain is trapped in a dark, silent box.
Yeah, that's very romantic of you.
Which is your skull. And the only information that it receives from your body and from the world, right, is through the senses, through the sense organs, your eyes, your ears, and you have sensory data that comes from your body that you're largely unaware of to your brain, which we call interoceptive, as opposed to exteroceptive, which is the world around you. But your brain is receiving sense data continuously, which are the effect of some set of causes. Your brain doesn't know the cause of these sense data. It's only receiving the effects of those causes, which are the data themselves. And so your brain has to solve what philosophers call an inverse inference problem. How do you know, when you only receive the effects of something, how do you know what caused those effects? So when there's a flash of light or a change in air pressure or a tug somewhere in your body, how does your brain know what caused those events so that it knows what to do next to keep you alive and well? And the answer is that your brain has one other source of information available to it, which is your past experience. It can reconstitute in its wiring past experiences, and it can combine those past experiences in novel ways. And so we have lots of names for this in psychology. We call it memory, we call it perceptual inference, we call it simulation. It's also, we call it concepts or conceptual knowledge. We call it prediction. Basically, if we were to stop the world right now, stop time, your brain is in a state and it's representing what it believes is going on in your body and in the world, and it's predicting what will happen next based on past experience, right? Probabilistically, what's most likely to happen. And it begins to prepare your action, and it begins to prepare your experience based. So it's anticipating the sense data it's going to receive. And then when those data come in, they either confirm that prediction and your action executes because the plan's already been made, or there's some sense data that your brain didn't predict that's unexpected, and your brain takes it in. We say encodes it. We have a fancy name for that. We call it learning. Your brain learns, and it updates its storehouse of knowledge, which we call an internal model, and so that you can predict better next time. And it turns out that predicting and correcting is a much more metabolically efficient way to run a system than constantly reacting all the time. Because if you're constantly reacting, it means you can't anticipate in any way what's going to happen. Mm-hmm. And so the amount of uncertainty that you have to deal with is overwhelming to a nervous system.
Metabolically costly. I like it.
And so what is a reflex? A reflex is when your brain doesn't check against the sense data, that the potential cost to you is so great, maybe because, your life is threatened, that your brain makes the prediction and executes the action without checking.
Yeah, but prediction is still at the core. That's a beautiful vision of the brain. I wonder, from almost an AI perspective, but just computationally, is the brain just mostly a prediction machine then? Like, is the perception just a nice little feature added on top? Like both the integration of new perceptual information. I wonder how big of an impressive system is that relative to just the big predictor, model constructor.
Well, I think that we can look to evolution for that, for one answer, which is that when you go back, 550 million years, give or take, the world was populated by creatures, really ruled by creatures without brains. That's a biological statement, not a political statement. Like, ruled with
You're
creatures
calling dinosaurs dumb? You're talking about like...
Oh, no, I'm not talking about dinosaurs, honey. Yeah. I'm talking way back, further back than that. Really, there are these little creatures called Amphioxus, which is the modern, or a lancet. That's the modern animal. But it's an animal that scientists believe is very similar to the common ancestor that we share with invertebrates, basically because of the tracing back the molecular genetics in cells. And that animal had no brain. It had some cells that would later turn into a brain, but in that animal, there's no brain. But that animal also had no head, and it had no eyes, and it had no ears, and it had really, really no senses. For the most part, it had very, very limited sense of touch. It had an eye spot for, not for seeing, but just for in training to circadian rhythm to light and dark. And it had no hearing. It had a vestibular cell so that it could keep upright in the water. At the time, we're talking evolutionary scale here, so, give or take some 100 million years or something. But at the time, what are the vertebrate, like when a backbone evolved and a brain evolved, a full brain, that was when a head evolved with sense organs, and when that's when your viscera, like internal systems, involved. So the answer, I would say, is that senses, motor neuroscientists, people who study the control of motor behavior, believe that senses evolved in the service of motor action. So the idea is that, like, what was the big evolutionary change? What was the big pressure that made it useful to have eyes and ears and a visual system and an auditory system and a brain, basically? And the answer that is commonly entertained right now is that it was predation. That when at some point an animal evolved that deliberately ate another animal, and this launched an arms race between predators and prey, and it became very useful to have senses, right? So these little amphioxy, don't really have they're not aware of their environment very much, really. And so being able to look up ahead and, ask yourself, should I eat that or will it eat me? Is a very useful thing. So the idea is that sense sense data is not there for consciousness. It didn't evolve for the purposes of consciousness. It didn't evolve for the purposes of experiencing anything. It evolved to be in the service of motor control. However, maybe it's useful. This is why, scientists sometimes avoid questions about why things evolved. That this is what philosophers call this teleology. You might be able to say something about how things evolve, but not necessarily why. We don't really know the why. That's all speculation.
But the why is kind of nice here. The interesting thing is that was the first element of social interaction is, am I going to eat you or are you going to eat me? And for that, it's useful to be able to see each other, sense each other. That's kind of fascinating. That there was a time when life didn't eat each other.
Or they did by accident, right? So an amphioxus, for example, will, it kind of like gyrates in the water and then it plants itself in the sand like a living blade of grass, and then it just filters whatever comes into its mouth, right? So it is eating, but it's not actively hunting. And when the concentration of food decreases, the amphioxus can sense this, and so it basically wriggles itself randomly to some other spot, which probabilistically will have more food than wherever it is. So it's not really, it's not guiding its actions on the basis of, it's not, we would say there's no real intentional action in the traditional sense.
Speaking of intentional action, and if the brain is, if prediction is indeed a core component of the brain, let me ask you a question that scientists also hate is about free will. So how does, do you think about free will much? How does that fit into this, into your view of the brain? Why does it feel like we make decisions in this world?
This is a hard, scientists hate this because it's a hard question. We don't know the answer to.
Have you taken a side?
I think
Do
I
we
have
free will?
I think I have taken a side, but I don't put a lot of stock in my own intuitions or anybody's intuitions about the cause of things, right? One thing we know about the brain for sure is that the brain creates experiences for us. My brain creates experiences for me. Your brain creates experiences for you in a way that lures you to believe that those experiences actually reveals the way that it works, but it doesn't. So
you don't trust your own intuition about
really
free will?
Not really. No, I mean, no, but I am also somewhat persuaded by, I think Dan Dennett wrote at one point, the philosopher Dan Dennett wrote at one point that I can't say it as eloquently as him, but people obviously have free will. They are obviously making choices. So it's, and so there is this observation that we're not robots and we can do some things like a little more sophisticated than an amphioxus. So here's what I would say. I would say that your predictions, your internal model that's running right now, right, that your ability to understand the sounds that I'm making and attach them to ideas is based on the fact that you have years of experience knowing what these sounds mean in a particular statistical pattern, right? I mean, that's how you can understand the words that are coming out of my
mouth.
Right. I think we did this once before too, didn't we? When we were...
I don't know. I would have to access my memory module.
I think when I was in the
class thing?
Yeah, I think we did it just like that, actually. So bravo.
Wow.
Yeah.
I have to go look back to the tape.
Yeah. Anyways, the idea though is that your brain is using past experience, and it can use past experience in so it's remembering, but you're not consciously remembering. It's basically re-implementing prior experiences as a way of predicting what's going to happen next. Yeah. And it can do something called conceptual combination, which is it can take bits and pieces of the past and combine it in new ways. So you can experience and make sense of things that you've never encountered before because you've encountered something similar to them. And so a brain, in a sense, is not just doesn't just contain information. It is information gaining, meaning it can create new information by this generative process. So in a sense, you could say, well, that maybe that's a source of free will. But I think really where free will comes from, or the kind of free will that I think is worth having a conversation about, is involves cultivating experiences for yourself that change your internal model. When you were born and you were raised in a particular context, that your brain wired itself to your surroundings, to your physical surroundings, and also to your social surroundings. So you were handed an internal model, basically. But when you grow up, the more control you have over where you are and what you do, you can cultivate new experiences for yourself. And those new experiences can change your internal model. And you can actually practice those experiences in a way that makes them automatic, meaning it makes it easier for your brain to make them again. And I think that is something like what you would call free will. You aren't responsible for the model that you were handed, that someone, your caregivers cultivated a model in your brain. You're not responsible for that model, but you are responsible for the one you have now. You choose what you expose yourself to. You choose how you spend your time. Not everybody has choice over everything,
right,
but everybody has a little bit of choice. And so I think that is something that I think is arguably called free will.
Yeah, there's this, like the ripple effects of the billions of decisions you make early on in life are so great that even if it's like all deterministic, just the amount of possibilities that are created and then the focusing of those possibilities into a single trajectory, that somewhere within that's free will. Even if it's all deterministic, that might as well be just the number of choices that are possible, and the fact that you just make one trajectory through those set of choices seems to be like something like that would be called free will. But it's still kind of sad to think like there doesn't seem to be a place where there's magic in there, where it is all just a computer.
Well, there's lots of magic, I would say, so far, because we don't really understand how all of this is exactly played out at I mean, scientists are working hard and disagree about some of the details under the hood of what I just described, but I think there's quite a bit of magic, actually. And also there's also stochastic firing of neurons. They're not purely digital in the sense that there's also analog communication between neurons, not just digital. So it's not just with firing of axons. And some of that there are other ways to communicate. And also there's noise in the system, and the noise is there for a really good reason. And that is the more variability there is, the more potential there is for your brain to be able to be information bearing. So basically, there are some animals that have clusters of cells. The only job is to inject noise, into their neural patterns.
So maybe noise is the source of free will.
So you can think about stochasticity or noise as a source of free will, or you can think of conceptual combination as a source of free will. You can certainly think about cultivating. You can't reach back into your past and change your past. People try by psychotherapy and so on, but what you can do is change your present, which becomes your past.
Well, let me
Right.
think about that sentence.
So one way to think about it is that you're continuously, this is a colleague of mine, a friend of mine said, so what you're saying is that people are continually cultivating their past. And I was like, that's very poetic.
Yeah.
Yes. You are continually cultivating your past as a means of controlling your future.
So you think, I guess the construction of the mental model that you use for prediction ultimately contains within it your perception of the past, like the way you interpret the past, or even just the entirety of your narrative about the past. So you're constantly rewriting the story of your past. Oh boy. Yeah. That's one, poetic and also just awe-inspiring. What about the other thing you talk about? You've mentioned about sensory perception as a thing that like is just, you have to infer about the sources of the thing that you have perceived through your senses. So let me ask another ridiculous question. Is anything real at all? Like, how do we know it's real? How do we make sense of the fact that, just like you said, there's this brain sitting alone in the darkness trying to perceive the world? How do we know that the world is out there to be perceived?
Yeah. So I don't think that you should be asking questions like that without
Yeah.
passing a joint.
Right. No, for sure.
Yeah.
I actually did
yeah.
before this, so I apologize.
Okay.
Yeah.
No, well, that's okay. You apologize for not sharing. That's
Yeah.
okay. So, I mean, here's what I would say. What I would say is that the reason why we can be pretty sure that there's a there is that the structure of the information in the world, what we call statistical regularities in sights and sounds and so on, and the structure of the information that comes from your body, it's not random stuff. There's a structure to it. There's a spatial structure and a temporal structure. And that spatial and temporal structure wires your brain. So an infant brain is not a miniature adult brain. It's a brain that is waiting for wiring instructions from the world. And it must receive those wiring instructions to develop in a typical way. So, for example, when a baby is born, the baby can't see very well because the visual system in that baby's brain is not complete. The retina of your eye, which actually is part of your brain, has to be stimulated with photons of light. If it's not, the baby won't develop normally to be able to see in a neurotypical way. Same thing is true for hearing. The same thing is true really for all your senses. So the point is that that the physical world, the sense data from the physical world, wires your brain so that you have an internal model of that world, so that your brain can predict well to keep you alive and well and allow you to thrive.
That's fascinating that the brain is waiting for a very specific kind of set of instructions from the world. Like not the specific, but a very specific kind of instructions.
Yeah. So scientists call it expectable input. The brain needs some input in order to develop normally. And so we are genetically, we, as I say in the book, we have the kind of nature that requires nurture. We can't develop normally without sensory input from the world and from the body. And what's really interesting about humans and some other animals too, but really seriously in humans, is the input that we need is not just physical, it's also social. In order for an infant, a human infant to develop normally, that infant needs eye contact, touch. It needs certain types of smells. It needs to be cuddled. It needs, right? So without social input, the brain, that infant's brain will not wire itself in a neurotypical way. And again, I would say there are lots of cultural patterns of caring for an infant. It's not like the infant has to be cared for in one way. Whatever the social environment is for an infant, that it will be reflected in that infant's internal model. So we have lots of different cultures, lots of different ways of rearing children. And that's an advantage for our species, although we don't always experience it that way. That is an advantage for our species. But if you just, feed and water a baby without all the extra social doodads, what you get is a profoundly impaired human.
Yeah, but nevertheless, you're kind of saying that the physical reality has a consistent thing throughout that keeps feeding these set of sensory information that our brains are constructed for. But
yeah, the cool thing though is that if you change the consistency, if you change the statistical regularities, so prediction error, your brain can learn it. It's expensive for your brain to learn it, and it takes a while for the brain to get really automated with it. But you had a wonderful conversation with David Eagleman, who just published a book about this, and gave lots and lots of really very, very cool examples, some of which I actually discussed in How Emotions Were Made, but not obviously to the extent that he did in his book. It's a fascinating book, and it speaks to the point that your internal model is always under construction, and therefore you always can modify your experience.
I wonder what the limits are. Like if we put it on Mars, or if we put it in virtual reality, or if we sit at home during a pandemic and we spend most of our day on Twitter and TikTok. Like, I wonder where the breaking point is, like the limitations of the brain's capacity to properly continue wiring itself.
Well, I think what I would say is that there are different ways to specify your question, right? Like, one way to specify it would be the way that David phrases it, which is, can we create a new sense? Like, can we create a new sensory modality? How hard would that be? What are the limits in doing that? But another way to say it is, what happens to a brain when you remove some of those statistical regularities, right? Like, what happens to an adult brain when you remove some of the statistical patterns that were there and they're not there anymore?
Are you talking about in the environment or in the actual, like, you remove eyesight, for example? Or
Well, either way. I mean, basically, one way to limit the inputs to your brain are to stay home and protect yourself.
I see, yeah.
Another way is to put someone in solitary confinement. Another way is to stick them in a nursing home. Not all nursing homes, but, but there are some, right, which really are where people are somewhat impoverished in the interactions and the variety of sensory stimulation that they get. Another way is that you lose a sense, right? But the point is, I think that, the human brain really likes variety, to say it in a, sort of Cartesian way. Variety is a good thing for a brain. And there are risks that you take when you restrict what you expose yourself to.
Yeah. There's all this talk of diversity. The brain loves it to the fullest definition and degree of diversity.
Yeah. I mean, I would say the only thing, basically, human brains thrive on diversity. The only place where we seem to have difficulty with diversity is with each other.
Yeah.
Right. But who wants to eat the same food every day? You never would. Who wants to wear the same clothes every day? I mean, my husband, if you ask him to close his eyes, he won't be able to tell you what he's wearing.
Yeah.
He'll buy 7 shirts of exactly the same style in different colors. But they are in different colors, right? It's not like he's wearing.
How would you then explain my brain, which is terrified of choice, and therefore I wear the same thing every time?
Well, you must be getting your diversity.
Elsewhere.
Well, first of all, you are a fairly sharp dresser, so there is that. But so you're getting some reinforcement for dressing the way that you do. But no, your brain must get diversity in
other places.
In other places. But I think so the two most expensive things your brain can do metabolically speaking is move your body and learn something new. So novelty, that is diversity, right, comes at a cost, a metabolic cost, but it's a cost. It's an investment that gives returns. And in general, people vary in how much they like novelty, unexpected things. Some people really like it. Some people really don't like it. And there's everybody in between. But in general, we don't eat the same thing every day. We don't usually do exactly the same thing in exactly the same order, in exactly the same place every day. The only place we have difficulty with diversity is in each other. And then we have considerable problems there, I would say, as a species.
Let me ask, I don't know if you're familiar with Donald Hoffman's work about this questions of reality. What are your thoughts of the possibility that the very thing we've been talking about, of the brain wiring itself from birth to a particular set of inputs, is just a little slice of reality? That there is something much bigger out there that we humans, with our cognitive capabilities, is just not even perceiving. That the thing we're perceiving is just a crappy, like Windows 95 interface onto a much bigger, richer set of complex physics that we're not even in touch with.
Well, without getting too metaphysical about it, I think we know for sure. It doesn't have to be the, crappy version of anything, but we definitely have we have a set of senses that are limited in very physical ways, and we're clearly not perceiving everything there is to perceive. That's clear. I mean, it's not that hard. We can't, without why do we invent scientific tools? It's so that we can overcome our senses and experience things that we couldn't otherwise, right. Whether they are, different parts of the visual spectrum, the light spectrum, or things that are too microscopically small for us to see or too far away for us to see. So clearly we're only getting a slice. And that slice, the interesting or potentially sad thing about humans is that whatever we experience, we think there's a natural reason for experiencing it. And we think it's obvious and natural and that it must be this way. And that all the other stuff isn't important. And that's clearly not true. Many of the things that we think of as natural are anything but. They're certainly real, but we've created them. They certainly have very real impacts, but we've created those impacts. And we also know that there are many things outside of our awareness that have tremendous influence on what we experience and what we do. So there's no question that that's true. I mean, just but the extent is how fantastic. Yeah, exactly. Really, the question is how fantastical is it?
Yeah, like what a lot of people ask me. Am I allowed to say this? I think I'm allowed to say this. I've eaten shrooms a couple times, but I haven't gone the full. I'm talking to a few researchers in psychedelics. It's an interesting scientifically place. Like, what is the portal you're entering when you take psychedelics? Or another way to ask is like dreams.
So let me tell you what I think, which is based on nothing. Like, it's just based on my, right? So I don't.
Your intuition.
It's based on my, I'm guessing now, based on what I do know, I would say. But I think that, think about what happens. So your brain's running this internal model, right. And it's all outside of your awareness. You feel the products, but you don't sense you have no awareness of the mechanics of it, right? It's going on all the time. And so one thing that's going on all the time that you're completely unaware of is that when your brain is basically asking itself, figuratively speaking, not literally, right? Like, how is the last time I was in this sensory array with this stuff going on in my body, and this chain of events which just occurred, what did I do next? What did I feel next? What did I see next? And so it doesn't come up with one answer. It comes up with a distribution of possible answers. And then there has to be some selection process. And so you have a network in your brain, a subnetwork in your brain, a population of neurons that helps to choose. I'm not talking about a homunculus in your brain or anything silly like that. This is not the soul. It's not the center of yourself or anything like that. But there is a set of neurons that weighs the probabilities and helps to select or narrow the field. Okay, and that network is working all the time. It's actually called the control network, the executive control network, or you can call it a frontoparietal, because the regions of the brain that make it up are in the frontal lobe and the parietal lobe. There are also parts that belong to the subcortical parts of your brain. It doesn't really matter. The point is that there is this network, and it is working all the time. Whether or not you feel in control, whether or not you feel like you're expending effort, doesn't really matter. It's on all the time, except when you sleep. When you sleep, it's a little bit relaxed. And so think about what's happening when you sleep. When you sleep, the external world recedes, the sense data so basically your model becomes a little bit, the tethers from the world are loosened. And this network, which is involved in, maybe weeding out unrealistic things, is a little bit quiet. So your dreams are really your internal model that's unconstrained by the immediate world. So you can do things that you can't do in real life in your dreams, right? You can fly. Like for example, when I fly on my back in a dream, I'm much faster than when I fly on my front. Don't ask me why. I don't know.
But when you're laying on your back in your dream?
No, when I'm in my dream and flying in a dream, I am much faster flyer in the air.
Fly often?
Not often, but
you talk about it like I don't think I've flown for many years.
Well, you must try it.
I've flown. I've fallen.
That's scary.
Yeah, but you're talking about like
airplane. I fly in my dreams, and I'm way faster, right?
On your back,
on my back, way faster. Now you can say, well, you never flew in your life, right? It's conceptual combination. I mean, I've flown in an airplane, and I've seen birds fly, and I've watched movies of people flying, and I know Superman probably flies. I don't know if he flies faster on his back, but
he's I've never seen
flying on his front, right? But
so.
Yeah. But anyways, my point is that all of this stuff really, all these experiences really become part of your internal model. The thing is that when you're asleep, your internal model is still being constrained by your body. Your brain's always attached to your body. It's always receiving sense data from your body. You're mostly never aware of it unless you run up the stairs or maybe you are ill in some way. But you're mostly not aware of it, which is a really good thing, because if you were, you'd never pay attention to anything outside your own skin ever again. Like right now, you seem like you're sitting there very calmly, but you have a virtual
whole thing going
drama,
on.
Right?
Yeah.
It's like an opera going on inside your body. And so I think that one of the things that happens when people take psilocybin or take ketamine, for example, is that the tethers
are completely removed.
Yeah.
That's fascinating. And then
and that's why it's helpful to have a guide, right? Because the guide is giving you sense data to steer that internal model so that it doesn't go completely off the rails.
Yeah, no, there's again, that wiring to the other brain, that's the guide, is at least a tiny little tether.
Exactly.
Yeah. Let's talk about emotion a little bit if we could. Emotion comes up often, and I have never spoken with anybody who has a clarity about emotion from a biological and neuroscience perspective that you do. And I'm not sure I fully know how to, I mentioned this way too much, but as somebody who was born in the Soviet Union and romanticizes basically everything, talks about love nonstop, emotion is I don't know what to make of it. I don't know so maybe let's just try to talk about it. I mean, from a neuroscience perspective, we talked about it a little bit last time. Your book covers it, how emotions are made, but what are some misconceptions we writers of poetry, we romanticizing humans have about emotion that we should move away from if we were to think about emotion from both a scientific and an engineering perspective?
Yeah, so there is a common view of emotion in the West. The caricature of that view is that, we have an inner beast, right? Your limbic system, your inner lizard. We have an inner beast, and that comes baked in to the brain at birth. So you've got circuits for anger, sadness, fear. It's interesting that they all have English names. These circuits are,
Yeah.
but and they're there, and they're triggered by things in the world, and then they cause you to do and say and So when your fear circuit is triggered, you widen your eyes, you gasp, your heart rate goes up, you prepare to flee or to freeze. And these are modal responses. They're not the only responses that you give, but on average, they're the prototypical responses. That's the view. And that's the view of emotion in the law. That's the view, that emotions are these profoundly unhelpful things that are obligatory, kind of like reflexes. The problem with that view is that it doesn't comport to the evidence. And it doesn't really matter. The evidence actually lines up beautifully with each other. It just doesn't line up with that view. And it doesn't matter whether you're measuring people's facial movements, or you're measuring their body movements, or you're measuring their peripheral physiology, or you're measuring their brains or their voices or whatever. Pick any output that you want to measure, and any system you want to measure, and you don't really find strong evidence for this. And I say this as somebody who not only has reviewed really thousands of articles and run big meta-analyses, which are statistical summaries of published papers, but also as someone who has sent teams of researchers to small-scale cultures, remote cultures, which are very different from urban, large-scale cultures like ours. And one culture that we visited, and I say we euphemistically because I myself didn't go because I only had 2 research permits, and I gave them to my students because I felt like it was better for them to have that experience and more formative for them to have that experience. But I was in contact with them every day by satellite phone. And this was to visit the Hadza hunter-gatherers in Tanzania, who are not an ancient people. They're a modern culture, but they live in circumstances, hunting and foraging circumstances that are very similar, in similar conditions to our ancestors, hunting-gathering ancestors, when expressions of emotion were supposed to have evolved, at least by one view of, okay. So, for many years, I was sort of struggling with this set of observations, right? Which is that I feel emotion, and I perceive emotion in other people, but scientists can't find a single marker, a single biomarker, not a single individual measure or pattern of measures that can predict what kind of emotional state they're in. How could that possibly be? How can you possibly make sense of those two things? And through a lot of reading and immersing myself in different literatures, I came to the hypothesis that the brain is constructing these instances out of more basic ingredients. So when I tell you that when I suggest to you that what your brain is doing is making a prediction, and it's asking itself, figuratively speaking, the last time I was in this situation and this physical state. What did I do next? What did I see next? What did I hear next? It's basically asking, what in my past is similar to the present?
Mm-hmm.
Things which are similar to one another are called a category. A group of things which are similar to one another is a category. And a mental representation of a category is a concept. So your brain is constructing categories or concepts on the fly continuously. So if you really want to understand what a brain is doing, using machine learning like classification models is not going to help you, because the brain doesn't classify. It's doing category construction.
Mm-hmm.
And the categories change, or you could say it's doing concept construction. It's using past experience to conjure a concept, which is a prediction.
Mm-hmm.
And if it's using past experiences of emotion, then it's constructing an emotion concept. Your concept will be, the content of it is changes depending on the situation that you're in. So, for example, if your brain uses past experiences of anger that you have learned, either because somebody labeled them for you, taught them to you, you observed them in movies and so on, in one situation could be very different from your concept for anger than another situation. And this is how instances of anger are what we call a population of variable instances. Sometimes when you're angry, you scowl. Sometimes when you're angry, you might smile.
Mm-hmm.
Sometimes when you're angry, you might cry. Sometimes your heart rate will go up, it will go down, it will stay the same. It depends on what action you're about to take. Because the way prediction, and I should say, the idea that physiology is yoked to action is a very old idea in the study of the peripheral nervous system that's been known for really decades. And so if you look at what the brain is doing, if you just look at the anatomy here's the hypothesis that you would come up with. And I can go into the details. I've published these details in scientific papers, and they also appear somewhat in How Emotions Are Made, my first book. They are not in the 7.5 lessons, because that book is really not pitched at that level of explanation.
Right.
It's really just a set of little essays. But what I'm about to say is actually based on scientific evidence. When your brain begins to form a prediction, the first thing it's doing is it's making a prediction of how to change the internal systems of your body, your heart, your cardiovascular system, the control of your heart, control of your lungs, right? A flush of cortisol, which is not a stress hormone. It's a hormone that gets glucose into your bloodstream very fast, because your brain is predicting you need to do something metabolically expensive. And so either that means either move or learn.
Mm-hmm.
Okay. And so your brain is preparing your body, the internal systems of your body, to execute some actions, to move in some way. And then it infers based on those motor predictions and what we call visceromotor predictions, meaning the changes in the viscera that your brain is preparing to execute. Your brain makes an inference about what you will sense based on those motor movements. So your experience of the world and your experience of your own body are a consequence of those predictions, those concepts. When your brain makes a concept for emotion, it's constructing an instance of that emotion. And that is how emotions are made.
And those concepts load in, the predictions that are made include contents inside the body, contents outside the body. I mean, it includes other humans. So just this construction of a concept includes the variables that are much richer than just some sort of simple notion.
Yeah. So our colloquial notion of a concept where, it, you know, where I say, well, what's a concept of a bird? And then you list a set of features off to me. That's people's understanding, typically of what a concept is. But if you go into the literature in cognitive science, what you'll see is that the way that scientists have understood what a concept is has really changed over the years. So people used to think about a concept as, philosophers and scientists used to think about a concept as a dictionary definition for a category. So there's a set of things which are similar out in the world, and your concept for that category is a dictionary definition of the features,
Right.
the necessary and sufficient features of those instances. So for a bird, it would be
Wings, feathers.
right, a beak.
Yeah.
It flies, whatever. Okay. That's called the classical category. And scientists observed that actually not all instances of birds have feathers and not all instances of birds fly. And so the idea was that you don't have a single representation of necessary and sufficient features stored in your brain somewhere. Instead, what you have is a prototype. A prototype meaning you still have a single representation for the category, one. But the features are like of the most typical instance of the category or maybe the most frequent instance, but not all instances of the category have all the features, right? They have some graded similarity to the prototype. And then, what I'm going to incredibly simplify now a lot of work to say that then a series of experiments were done to show that, in fact, what your brain seems to be doing is coming up with a single exemplar or instance of the category and reading off the features when I ask you for the concept. So if we were in a pet store and I asked you, what are the features of a bird? Tell me the concept of bird. You would be more likely to give me features of a good pet. Mm-hmm. And if we were in a restaurant, you would be more likely, like a budgie, right? Or a canary. If we were in a restaurant, you would be more likely to give me the features of a bird that you would eat, like a chicken. Yeah. And if we were in a park, you'd be more likely to give me, in this country, the features of a sparrow or a robin. Whereas if we were in South America, you would probably give me the features of a peacock because that's more common. Or it is more common there than here that you would see a peacock in such circumstances. So the idea was that really what your brain was doing was conjuring a concept on the fly that meets the function that the category is being put to. Okay?
Yep.
Okay. Then people started studying ad hoc concepts, meaning concepts where the instances don't share any physical features, but the function of the instances are the same. So, for example, think about all the things that can protect you from the rain. What are all the things that can protect you from the rain?
Umbrella, like this apartment.
Right.
Your
car.
Not giving a damn. like a mindset.
Yeah, right. So the idea is that the function of the instances is the same in a given situation, even if they look different, sound different, smell different. This is called an abstract concept or a conceptual concept. Yeah. Now, the really cool thing about conceptual categories or conceptual conceptual category or conceptual is a category of things that are held together by a function, which is called an abstract concept or a conceptual category, because the things don't share physical features, they share functional features. There are two really cool things about this. One is that's what Darwin said a species was. So Darwin is known for discovering natural selection. But the other thing he really did, which was really profound, which he's less celebrated for, is understanding that all biological categories have inherent variation. Inherent variation. Darwin wrote in The Origin of Species about, before Darwin's book, a species was thought to be a classical category where all the instances of dogs were the same, had exactly the same features, and any variation from that perfect Platonic instance was considered to be error. And Darwin said, no, it's not error, it's meaningful. Nature selects on the basis of that variation. The reason why natural selection is powerful and can exist is because there is variation in a species. And in dogs, we talk about that variation in terms of the size of the dog and the amount of fur the dog has and the color and how long is the tail and how long is the snout. In humans, we talk about that variation in all kinds of ways, right? Including in cultural ways. So that's one thing that's really interesting about conceptual categories, is that Darwin was basically saying a species is a conceptual category. Yeah. And in fact, if you look at modern debates about what is a species, you can't find anybody agreeing on what the criteria are for a species, because they don't all share the same genome. There isn't a single human genome. There's a population of genomes, but they're variable. It's not unbounded variation, but they are variable, right? And the other thing that's really cool about conceptual categories is that they are the categories that we use to make civilization. So think about money, for example. What are all the physical things that make something a currency? Is there any physical feature that all the currencies in all the worlds that's ever been used by humans share?
Well, certainly, right. But what is it? Is it definable? It's getting to the point that you're making its function.
It's the function,
it's the
right?
Function.
It's that we trade it for material goods, and we have to agree, right? We all impose on whatever it is: salt, barley, little shells, big rocks in the ocean that can't move, Bitcoin, pieces of plastic, mortgages, which are basically a promise of something in the future, nothing more, right? All of these things, we impose value on them. And we all agree that we can exchange them for material goods.
Yeah, and yes, that's brilliant. By the way, you're attributing some of that to Darwin, that he thought.
I'm saying that what Darwin,
because it's a brilliant view of what a species is the function.
What I'm saying is that what Darwin really talked about variation in. So if you read, for example, the biologist Ernst Mayr, who was an evolutionary biologist, and then when he retired, became a historian and philosopher of biology, and his suggestion is that Darwin did talk about variation. He vanquished what's called essentialism, the idea that there's a single set of features that define any species. And out of that grew really discussions of the function, like some of the functional features that species have, like they can reproduce, they can have offspring. The individuals of a species can have offspring. Well, it turns out that's not a perfect, criterion to use, but it's a functional criterion, right? So what I'm saying is that in cognitive science, people came up with the idea, they discovered the idea of conceptual categories or ad hoc concepts, these concepts that can change based on the function they're serving, right? And that it's there. Darwin, it's in Darwin, and it's also in the philosophy of social reality. The way that philosophers talk about social reality, just look around you. I mean, we're treating a bunch of things as similar, which are physically different. And sometimes we take things that are physically the same and we treat them as separate categories.
But it feels like the number of variables involved in that kind of categorization is nearly infinite. And that's
No, I don't think so, because there is a physical constraint, right? Like you and I could agree that we can fly in real life, but we can't. That's a physical constraint that we can't break, right? You and I could agree that we could walk through the walls,
right.
But we can't. We could agree that we could eat glass, but
there's a lot of constraints. But
we could agree that the virus doesn't exist and we don't have to wear masks.
Right. Yeah.
But, physical reality still holds the trump card, right? But still, there's a lot of
card. Well, pun unintended.
Pun completely unintended, but there you go. That's a predicting brain for you. But there's a tremendous amount of leeway.
Yes.
Yeah, that's the point. So what I'm saying is that emotions are like money. Basically, they're like money. They're like countries. They're like kings and queens and presidents. They're like everything that we construct, that we impose meaning on. We take these physical signals and we give them meanings that they don't otherwise have by their physical nature. And because we agree, they have that function.
But the beautiful thing, so maybe unlike money, I love this similarity, is it's not obvious to me that this kind of emergent agreement should happen with emotion, because our experiences are so different for each of us humans, and yet we kind of converge.
Well, in a culture we converge, but not across cultures. There are huge, huge differences. There are huge differences in what concepts exist, what they look like. So what I would say is that
they feel like
what we're doing with our young children as their brains become wired to their physical and their social environment, right, is that we are curating for them. We are bootstrapping into their brains a set of emotion concepts. Mm-hmm. That's partly what they're learning. And we curate those for infants just the way we curate for them what is a dog, what is a cat, what is a truck. We sometimes explicitly label, and we sometimes just use mental words. When, your kid is, throwing Cheerios on the floor instead of eating them, or your kid is crying when, she won't put herself to sleep or whatever. We use mental words, and a word is for infants, words are these really special things that they help infants learn abstract categories. There's a huge literature showing that children can take things that don't look like infants, really young infants, pre-verbal infants, can take, if I say to you, and you're an infant, okay, so I say, Lexi, this is a bling.
Yeah.
And I put it down and the bling makes a squeaky noise. Yeah. And then I say,
I'm
Lexi,
getting excited, by the way.
This is a bling. And I put it down and it makes a squeaky noise. And then I say, Lexi, this is a bling. You, as young as 4 months old, will expect this to make a noise.
Yeah.
A squeaky noise. And if you don't, if it doesn't, you'll be surprised because it violated your expectation, right? Yeah. I'm building for you an internal model of a bling.
Yeah.
Okay. Infants can do this really, really at a young age. And so there's no reason to believe that they couldn't learn emotion categories and concepts in the same way. And what happens when you go to a new culture? When you go to a new culture, you have to do what's called emotion acculturation. So my colleague Batya Mesquita in Belgium studies emotion acculturation. She studies how when people move from one culture to another, how do they learn the emotion concepts of that culture? How do they learn to make sense of their own internal sensations and also the movements, the raise of an eyebrow, the tilt of a head? How do they learn to make sense of cues from other people using concepts they don't have, but have to make on the fly?
So that's the difference between cultures. Let me open another door. I'm not sure I want to open, but difference between men and women. Is there difference between the emotional lives of those two categories of biological systems?
So here's what I would say. We did a series of studies um, in the 1990s where we asked men and women to tell us about their emotional lives. And women described themselves as much more emotional than men. They believed that they were more emotional than men, and men agreed. Women are much more emotional than men. Okay. And then we gave them little handheld computers. These were little Hewlett-Packard computers. They fit in the palm of your hand. They weighed a couple of pounds. So this was like pre-Palm Pilot even. Like this was, 1990s and like early. And we asked them, we would, ping them like 10 times a day and just ask them to report how they were feeling, which is called experience sampling. So we experience sampled. And then at the end, and then we looked at their reports, and what we found is that men and women basically didn't differ. And there were some people who were really had many more instances of emotion. So they were, they were treading water in a tumultuous sea of emotion. And then there were other people who were like floating tranquilly, in a lake. It was really not perturbed very often, and everyone in between. But there were no difference between men and women. And the really interesting thing is at the end of the sampling period, we asked people, reflect over the past 2 weeks and tell it. So, we've been now pinging people like again and again and again, right? So tell us how emotional do you think you are? No change from the beginning. So men and women believe that they believe that they are different. And when they are looking at other people, they make different inferences about emotion. If a man is scowling, like if you and I were together and somebody's watching this, okay? And yeah, hey, we were saying, hey, hi, yeah, hi.
By the way, people love it when you look at the camera.
If you and I make exactly the same set of facial movements, when people look at you, both men and women look at you, they are more likely to think, oh, he's reacting to the situation. And when they look at me, they'll say, oh, she's having an emotion. She's, yeah. And I wrote about this actually right before the 2016 election.
You know what? Maybe I could confess. Let me try to carefully confess.
But you are really going to.
Yeah. That when that there is an element when I see Hillary Clinton that there was something annoying about her to me. And I just that feeling, and then I tried to reduce that to what is that? Because I think the same attributes that are annoying about her when I see in other people wouldn't be annoying. So I was trying to understand what is it? Because it certainly does feel like that concept that I've constructed in my mind.
Well, I'll tell you that I think, well, let me just say that that what you would predict about, for example, the performance of the two of them in the debates, and I wrote an op-ed for the New York Times actually before the second debate, and it played out really pretty much as I thought that it would, based on research. It's not like I'm like a great fortune teller or anything. It's just I was just applying the research, which was that when a woman's people make internal attributions, it's called. They infer that the facial movements and body posture and vocalizations of a woman reflect her inner state. But for a man, they're more likely to assume that they reflect his response to the situation. It doesn't say anything about him. It says something about the situation he's in.
That's brilliant.
Now, for the thing that you were describing about Hillary Clinton, I think a lot of people experienced, but it's also in line with research, which shows, and particularly research actually on about teaching evaluations is one place that you really see it, where The expectation is that a woman will be nurturant and that a man, there's just no expectation for him to be nurturant. So he's, if he is nurturant, he gets points. If he's not, he gets points.
Right.
They're just different points, right? Whereas for a woman, especially a woman who's an authority figure, she's really in a catch-22.
Right.
Because if she's serious, she's a bitch. And if she's empathic, then she's weak.
Right. That's brilliant. I mean, one of the bigger questions to ask here, so that's one example where our construction of concepts gets us in trouble.
But remember I said science and philosophy are like tools for living. Yeah. So I learned recently that if you ask me, what is my intuition about what regulates my eating? I will say carbohydrates. I love carbohydrates. I love pasta. I love bread. I just love carbohydrates. Yeah. But actually, research shows, and it's beautiful research. I love this research because it so violates my own, like, deeply, deeply held beliefs about myself, that most animals on this planet who have been studied, and there are many, actually eat to regulate their protein intake. Hmm. So you will overeat carbohydrates in order to get enough protein. And this research has been done with very beautiful research with humans, with crickets, with bonobos. I mean, just like all these different animals, not bonobos, but I think like baboons. Now that I have no intuition about that. And even now, as I regulate my eating, I just have no intuition. I can't feel it. What I feel is only about the carbohydrates.
It feels like you're regulating around carbohydrates, not the protein.
Yeah. But in fact, actually, what I am doing, if I am like most animals on the planet, I am regulating around protein. So knowing this, what do? I correct my behavior to eat, to actually deliberately try to focus on the protein. Mm-hmm. This is the idea behind bias training, right? Like if you, I also did not experience Hillary Clinton as the warmest candidate. However, you can use consistent science, consistent scientific findings to organize your behavior. That doesn't mean that rationality is the absence of emotion, because sometimes emotion or feelings in general, not the same thing as emotion. That's another topic. But are a source of information and their wisdom and helpful. So I'm not saying that, but what I am saying is that if you have a deeply held belief and the evidence shows that you're wrong, then you're wrong. It doesn't really matter how confident you feel. That confidence could be also explained by science, right? So it would be the same thing as if regardless of whether someone is like Charlie Baker, right? Regardless of whether somebody is a Republican or a Democrat, if that person has a record that you can see is consistent with what you believe, then that is information that you can act on.
Yeah. And then, so try to, I mean, this is kind of what empathy is and open-mindedness is try to consider that the set of concepts that your brain has constructed through which you are now perceiving the world is not painting the full picture. I mean, this is now true for basically it doesn't have to be men and women. It could be basically the prism through which we perceive actually the political discourse, right?
Absolutely. So here's what I would say. There are scientists who will talk to you about cognitive empathy and emotional empathy. And I prefer to think of it, I think the evidence is more consistent with what I'm about to say, which is that your brain is always making predictions using your own past experience and what you've learned from, books and movies and other people telling you about their experiences and so on. And if your brain cannot make a concept to make sense of those, anticipate what those sense data are and make sense of them, you will be experientially blind. So, when I'm giving lectures to people, I'll show them like a blobby black and white image. and they're experientially blind to the image. They can't see anything in it. And then I show them a photograph, and then I show them the image again, the blobby image, and then they see actually an object in it. But
Awesome.
but the image is the same.
Yeah.
It's they're actually adding, their predictions now are adding, right? Or
It's a beautiful example.
Anybody who's learned a language, a second language after their first language, also has this experience of things that initially sound like sounds that they can't quite make sense of eventually come to make sense of them. And in fact, there are really cool examples of people who were like born blind because they have cataracts, or they have corneal damage, so that no light is reaching the brain. And then they have an operation, and then light reaches the brain, and they can't see for days and weeks and sometimes years. They are experientially blind to certain things. So what happens with empathy, right, is that your brain is making a prediction. And if it doesn't have the capacity to if you're not similar, remember, categories are instances which are similar in some way. If you are not similar enough to that person, you will have a hard time making a prediction about what they feel. You will be experientially blind to what they feel. In the United States, children of color are under-prescribed medicine by their physicians. This has been documented. It's not that the physicians are racist necessarily, but they might be experientially blind. The same thing is true of male physicians with female patients. I could tell you some hair-raising stories, really, where people die as a consequence of a physician making the wrong inference, the wrong prediction, because of being experientially blind. So we are, empathy is not, it's not magic. We make inferences about each other, about what each other's feeling and thinking. In this culture, there are some cultures where, people have what's called opacity of mind, where they will make a prediction about someone else's actions, but they're not inferring anything about the internal state of that person. But in our culture, we're constantly making inferences. What is this person thinking? And we're not doing it necessarily consciously, but we're just doing it really automatically using our predictions, what we know. And if you expose yourself to information which is very different from somebody else, really what we have is we have different cultures in this country right now there are a number of reasons for this. Part of it is, I don't know if you saw the Social Dilemma, the Netflix.
Heard about it.
Yeah, it's really great documentary. And
about what social networks are doing to our society?
Yeah. But, no phenomenon has a simple single cause. There are multiple small causes which all add up to a perfect storm. That's just, how most things work. And so the fact that machine learning algorithms are serving people up information on social media that is consistent with what they've already viewed and making, is part of the reason that you have these silos, but it's not the only reason why you have these silos. I think there are other things afoot that enhance people's inability to even have a decent conversation.
Yeah, okay, so many things you said are just brilliant. So the experiential blindness, but also from my perspective, like I preach and I try to practice empathy a lot, and something about the way you've explained it makes me almost see it as a kind of exercise that we should all do, like to train, like to add experiences to the brain to expand its capacity to predict more effectively.
Absolutely.
So like what I do is kind of like a method acting thing, which is I imagine what the life of a person is like, you know, just think. I mean, this is something you see with Black Lives Matter and police officers. It feels like they're both, not both, but I have, because of martial arts and so on, I have a lot of friends who are cops. They don't necessarily have empathy or visualize the experience of the other. Certainly, currently, unfortunately, people aren't doing that with police officers. They're not imagining, they're not empathizing or putting themselves in the shoes of a police officer to realize how difficult that job is, how dangerous it is, how difficult it is to maintain calm and under so much uncertainty, all those kinds of things.
But there's more, that's true. But I think that there's even more to be said there. I mean, like from a predicting brain standpoint, there's even more that can be said there. So I don't know if you want to go down that path or you want to stick on empathy, but I will also say that one of the things that I was most gratified by, I still am receiving, it's been more than 3.5 years since How Emotions Are Made came out, and I'm still receiving daily emails from people, right? So that's gratifying. But one of the most gratifying emails I received was from a police officer in Texas who told me that he thought that How Emotions Are Made contained information that would be really helpful to resolving some of these difficulties. And he hadn't even read my op-ed piece about when is a gun not a gun, and like using what we know about the science of perception from a prediction standpoint, like the brain is a predictor, to understand a little differently what might be happening in these circumstances. So there's a real, it's hard to talk about because everyone gets mad at you when you talk about this, and there is a way to understand this, which has profound empathy for the suffering of people of color, and that definitely is in line with Black Lives Matter, at the same time as understanding the really difficult situation that police officers find themselves in. And I'm not talking about this bad apple or that bad apple. I'm not talking about police officers who are necessarily shooting people in the back as they run away. I'm talking about the cases of really good, well-meaning cops who have the kind of predicting brain that everybody else has. They're in a really difficult situation that I think both they and the people who are harmed don't realize. Like the way that these situations are constructed, I think it's just, there's a lot to be said there, I guess, is what I want to say.
Is there something we can try to say in a sense, like what I'm, from the perspective of the predictive brain, which is a fascinating perspective to take on this, all the protests that are going on, there seems to be a concept of a police officer being built.
No, I think that concept is there,
but it's gaining strength. So it's being
yeah, it is.
Sure,
yeah,
it is
for sure.
there.
But I think, yeah, for sure, I think that that's right. I think that there's a shift in the stereotype of what I would say is a stereotype. There's a stereotype of Black man in this country that's always in movies and television, not always, but like largely, that many people watch. I mean, you think you're watching a 10 o'clock drama and all you're doing is like kicking back and relaxing, but actually you're having certain predictions reinforced and others not. And what's happening now with police is the same thing. That there are certain stereotypes of a police officer that are being abandoned and other stereotypes that are being reinforced by what you see happening. All I'll say is that if you remember, I mean, there's a lot to say about this, really, that, regardless of whether it makes people mad or not, I mean, the science is what it is.
Yeah.
just remember what I said. The brain makes predictions about internal changes in the body first, and then it starts to prepare motor action. And then it makes a prediction about what you will see and hear and feel based on those actions. Okay? So it's also the case that we didn't talk about is that sensory sampling, like your brain's ability to sample what's out there, is yoked to your heart rate. It's yoked to your heartbeats. There are certain phases of the heartbeat where it's easier for you to see what's happening in the world than at others. And so if your heart rate goes through the roof, you will be more likely to just go with your prediction and not correct based on what's out there, because you're actually literally not seeing as well. Or you will see things that aren't there, basically.
Is there something that we could say by way of advice for when this episode is released in the chaos of emotion? Sorry, I don't know a better term. That's just flying around on social media. What's
Well, I actually think it is emotion in the following sense. And it sounds a little bit like artificial in the way that I'm about to say it, but I really think that this is what's happening. One thing we haven't talked about is, brains didn't evolve for you to see, they didn't evolve for you to hear, they didn't evolve for you to feel, they evolved to control your body. That's why you have a brain. You have a brain so that it can control your body. And the metaphor, there's the scientific term for predictively controlling your body is allostasis. Your brain is attempting to anticipate the needs of your body and meet those needs before they arise so that you can act as you need to act. And the metaphor that I use is a body budget. Your brain is running a budget for your body. It's not budgeting money, it's budgeting glucose and salt and water. And instead of having, one or two bank accounts, it has gazillions. There are all these systems in your body that have to be kept in balance. And it's monitoring very closely. It's making predictions about, like, when is it good to spend and when is it good to save and what would be a good investment and am I going to get a return on my investment? Whenever people talk about reward or reward prediction error or anything to do with reward or punishment, they're talking about the body budget. They're talking about your brain's predictions about whether or not there will be a deposit or withdrawal. So when your brain is running a deficit in your body budgets, you have some kind of metabolic imbalance, you experience that as discomfort. You experience that as distress. When things are chaotic, you can't predict what's going to happen next. So I have this absolutely brilliant scientist working in my lab. His name is Jordan Theriault, and he's published this really terrific paper on a sense of should. Like, why do we have social rules? Why do we, adhere to social norms? It's because if I make myself predictable to you, then you are predictable to me. And if you're predictable to me, that's good because that is less metabolically expensive for me. Novelty or unpredictability at the extreme is expensive. And if it goes on for long enough, what happens is, first of all, you will feel really jittery and antsy, which we describe as anxiety. Mm-hmm. It isn't necessarily anxiety. It could be just something is not predictable and you are experiencing arousal because the chemicals that help you learn increase your feeling of arousal, basically. Mm-hmm. But if it goes on for long enough, you will become depleted. And you will start to feel really, really, really distressed. So what we have is a culture full of people right now who their body budgets are just decimated. Yeah. And there's a tremendous amount of uncertainty. when you talk about it as depression and anxiety, it makes you think that it's not about your metabolism, that it's not about your body budgeting, that it's not about getting enough sleep or about eating well or about making sure that you have social connections. It's, you think that it's something separate from that. But depression and anxiety are just a way of being in the world. They're a way of being in the world when things aren't quite right with your predictions.
That's such a deep way of thinking. Like the brain is maintaining homeostasis.
It's actually allostasis.
Allostasis. I'm sorry, and it's constantly making predictions. And metabolically speaking, it's very costly to make novel, like constantly be learning to making adjustments. And then over time, there's cost to be paid if you're just in a place of chaos where there's constant need for adjusting and learning and experience novel things.
And so part of the problem here, there are a couple of things. Like I said, it's a perfect storm. There isn't a single cause.
Right.
There are multiple causes, multiple things that combine together. It's a complex system, multiple things. Part of it is that people they're metabolically encumbered and they're distressed. And in order to try to have empathy for someone who is very much unlike you, you have to forage for information. You have to explore information that is novel to you and unexpected. And that's expensive. And at a time when people feel, what do you do when you are running a deficit in your bank account? You stop spending. What does it mean for a brain to stop spending? A brain stops moving very much, stops moving the body, and it stops learning. It just goes with its internal model.
Brilliantly put, yep.
So empathy requires, to have empathy for someone who is unlike you, requires learning and practice. You're foraging for information. I mean, it is something I talk about in the book, in 7.5 Lessons About the Brain. I think it's really important. It's hard, but it's hard. I think it's, it's hard for people to be curious about views that are unlike their own when they feel so encumbered. And I'll just tell you, I had this epiphany, really. I was listening to Robert Reich's The System. He was talking about oligarchy versus democracy. And so oligarchy is where very wealthy people, like extremely wealthy people, shift power so that they become even more wealthy and even more insulated and from the pressures of the common person. It's actually the kind of system that leads to the collapse of civilizations, if you believe Jared Diamond. Mm-hmm. Just say that. But anyways, I'm listening to this, and I'm listening to him describe in fairly decent detail how the CEOs of these companies, there's been a shift in what it means to be a CEO and no longer being a steward of the community and so on. But like in the 1980s, it sort of shifted to this other model of being like an oligarch. And he's talking about how, it used to be the case that that CEOs made like 20 times what their employees made. And now they make about 300 times on average what their employees made. So where did that money come from? It came from the pockets of the employees. And they don't know about it, right? No one knows about it. They just know they can't feed their children. They can't pay for health care. They can't take care of their family. And they worry about what's going to happen to they're living like, month to month, basically. Any one big bill could completely, put them out on the street. So there are a huge number of people living like this. So what they're experiencing, they don't know why they're experiencing it. So and then someone comes along and gives them a narrative.
Yeah.
Well, somebody else butted in line in front of you. And that's why you're this way. That's why you experience what you're experiencing. Just for a minute, I was thinking, I had deep empathy for people who have beliefs that are really, really, really different from mine. But I was trying really hard to see it through their eyes.
Yeah.
And did it cost me something metabolically? I'm sure.
Yeah.
I'm sure.
But you had something in the gas tank.
Well,
in order to allocate that. I mean, that's the question is like, where did you what resources did your brain draw on in order to actually make that effort?
Well, I'll tell you something, honestly, Lex. I don't have that much in the gas tank right now. Right? So I am surfing the stress that, stress is just, what is stress? Stress is your brain is preparing for a big metabolic outlay, and it just keeps preparing and preparing and preparing and preparing.
You as a professor, you as a human?
Both, right? For me, this is a moment of existential crisis as much as anybody else, democracy, all of these things. So in many of my roles, I guess what I'm trying to say is that I get up every morning and I exercise. I run, I row, I lift weights, right? You exercise in the middle of the day. Yeah. I saw your daily
I'm
thing.
Obsessed with it.
Yeah. I hate it, actually. Yeah. You love it, right?
No, I hate it.
I hate it, but I do it religiously.
Yeah.
Why? Because it's a really good investment. It's an expenditure that is a really good investment. And so when I was exercising, I was listening to the book. And when I realized the insights that I was sort of like playing around with, like, does this make sense? Does this make sense? I didn't immediately plunge into it. I basically wrote some stuff down. I set it aside. And then I did what I prepared myself to make an expenditure. I don't know what you do before you exercise. I always have a protein shake, because I need to fuel up before I make this really big expenditure. And so I did the same thing. I didn't have a protein drink, but I did the same thing. And fueling up can mean lots of different things. It can mean talking to a friend about it. It can mean, it can mean making sure you get a good night's sleep before you do it. It can mean lots of different things. But I guess I think we have to do these things.
I'm going to re-listen to this conversation several times. This is brilliant. But I do think about, I've encountered so many people that can't possibly imagine that a good human being can vote for Donald Trump. And I've also encountered people that can't imagine that an intelligent person can possibly vote for a Democrat. And I look at both these people, many of whom are friends, and let's just say after this conversation, I can see as their predicting brains not willing to invest the resources to empathize with the other side. And I think you have to, in order to be able to see the obvious common humanity in us. I don't know what the system is that's creating this division. We can put it, like you said, it's a perfect storm. It might be the social media. It might be, I don't know what the hell it is.
I think it's a bunch of things. Right. I think it's
just coming together.
There's an economic system which is disadvantaging large numbers of people. There's a use of social media. Like if I had to orchestrate or architect a system that would screw up a human body budget, it would be the one that we live in. We don't sleep enough. We eat pseudo food, basically. We are on social media too much, which is full of ambiguity, which is really hard for a human nervous system, right? Really, really hard. Like ambiguity with no context to predict in. I mean, it's like really. And then, there are the economic concerns that affect large swaths of people in this country. I mean, it's really, I'm not saying everything is reducible to metabolism. Not everything is reducible to metabolism, but if you combine all these things together,
it's helpful to think of it that way. Then somehow it's also somehow reduces the entirety of the human experience to the same kind of obvious logic. Like we should exercise every day in the same kind of way. We should empathize every day.
Yeah. There are these really wonderful, wonderful programs for teens and sometimes also for parents of people who've lost children in wars and in conflicts, in political conflicts, where they go to a bucolic setting and they talk to each other about their experiences. And miraculous things happen, So, um, uh, it's easy to sort of shrug this stuff off as kind of Pollyanna-ish, like what's this really going to do? But um, you have to think about when my daughter went to college. I gave her advice. I said, try to be around people who let you be the kind of person you want to be. We're back to free will. You have a choice. You have a choice. It might seem like a really hard choice. It might seem like a unimaginably difficult choice. But you have a choice. Do you want to be somebody who is wrapped in fury and agony, or do you want to be somebody who extends a little empathy to somebody else, and in the process maybe learn something? Yeah. Curiosity is the thing that protects you. Curiosity is the thing. It's curative curiosity.
On social media, the thing I recommend to people, at least that's the way I've been approaching social media. It doesn't seem to be the common approach, but I basically give love to people who seem to also give love to others. So it's the same similar concept of surrounding by yourself by the people you want to become. And I ignore, sometimes block, but just ignore. I don't add aggression to people who are just constantly full of aggression and negativity and toxicity. There's a certain desire when somebody says something mean to say something, to say why or try to alleviate the meanness and so on. But what you're doing essentially is you're now surrounding yourself by that group of folks that have that negativity. So even just the conversation. So I think it's just so powerful to put yourself amongst people who are whose basic mode of interaction is kindness. Because I don't know what it is, but maybe it's the way I'm built, is that to me is energizing for the gas tank of that. Then I can pull to,
for sure,
when I start reading The Rise and Fall of the Third Reich and start thinking about Nazi Germany. I can empathize with everybody involved. I can start to make these difficult thinking that's required to understand our little planet Earth.
Well, there is research to back up what you said. There's research that's consistent with your intuition there. That there's research that shows that being kind to other people, doing something nice for someone else, is like making a deposit to some extent. Because I think making a deposit not only in their body budgets, but also in yours. People feel good when they do good things for other people. We are social animals. We regulate each other's nervous systems for better and for worse, right? The best thing for a human nervous system is another human. And the worst thing for a human nervous system is another human. So you decide. Do you want to be somebody who makes people feel who makes people feel better, or do you want to be somebody who causes people pain? And we are more responsible for one another than we might like or than we might want. But remember what we said about social reality, social reality. So there are lots of different cultural norms about, independence or collective, nature of people. But the fact is we have socially dependent nervous systems. We evolved that way as a species. And in this country, we prize individual rights and freedoms. And that is a dilemma that we have to grapple with. And we have to do it in a way, if we're going to be productive about it, we have to do it in a way that requires engaging with each other, and which is what I understand the founding members of this country intended.
Beautifully put. Let me ask a few final silly questions. So one, talked a bit about love, but let me. It's fun to ask somebody like you who can effectively, from at least neuroscience perspective, disassemble some of these romantic notions. But what do you make of romantic love? Why do human beings seem to fall in love? At least a bunch of '80s hair bands have written about it. Is that a nice feature to have? Is that a bug? What is it?
Well, I'm really happy that I fell in love. I wouldn't want it any other way. But I would say,
Is that you, the person speaking, or the neuroscientist?
that's me, the person speaking. Yeah. But I would say, as a neuroscientist, babies are born not able to regulate their own body budgets because their brains aren't fully wired yet. When you feed a baby, when you cuddle a baby, everything you do with a baby impacts that baby's body budget and helps to wire that baby's body budget, helps to wire that baby's brain to manage eventually her own body budget to some extent. That's the basis biologically of attachment. Humans evolved as a species to be socially dependent, meaning you cannot manage your body budget on your own without a tax that eventually you pay many years later in terms of some metabolic illness, right? Loneliness, when you break up with someone that you love or you lose them, right? You feel like it's going to kill you, but it doesn't. But loneliness will kill you. It will kill you approximately, 7 years earlier. I can't remember exactly the exact number. It's actually in the web notes to 7.5 Lessons. But social isolation and loneliness will kill you earlier than you would otherwise die. And the reason why is that you didn't evolve to manage your nervous system on your own. And when you do, you pay a little tax, and that tax accrues very slightly over time, over a long period of time, so that by the time you're in, middle-aged or a little older, you are more likely to die sooner from some metabolic illness, from heart disease, from diabetes, from depression. You're more likely to develop Alzheimer's disease. I mean, it takes a long time for that tax to accrue, but it does. So yes, I think it's a good thing for people to fall in love.
But I think the funny view of it is that it's clear that humans need the social attachment to manage their nervous system as you're describing. And the reason you want to stay with somebody for a long time is so you don't have the novelty is very costly for our.
Well, now you're mixing things. Now you're no, you have to decide whether. Yeah. But what I would say is when you lose someone you love, it feels like you've lost a part of you, and that's because you've lost someone who was contributing to your body budget. We are the caretakers of one another's nervous systems, like it or not, and out of that comes very deep feelings of attachment, some of which are romantic love.
Are you afraid of your own mortality? We two humans sitting here.
Yeah.
Do you ponder your own mortality? I mean, you're somebody who thinks about your brain a lot. It seems one of the more terrifying, or I don't know how to feel about it, but it seems to be one of the most definitive aspects of life is that it ends.
It's a complicated answer, but I think the best I can do in a short snippet would be to say, for a very long time, I did not fear my own mortality. I feared pain and suffering. So That's what I feared. I feared being harmed or dying in a way that would be painful. But I didn't fear having my life be over. Now, as a mother, I think I have fear. I fear dying before my daughter is ready to be without me. That's what I fear. That's really what I fear. And frankly, honestly, I fear my husband dying before me much more than I fear my own death.
There's that love and social attachment again.
Yeah, because I know it's just I'm gonna feel like I wish I was dead.
Yeah. A final question about life. What do you think is the meaning of it all? What's the meaning of life?
Yeah, I think that there isn't one meaning of life. There's like many meanings of life. And, you use different ones on different days. But for me,
depending on the day.
Depending on the day. But for me, I would say sometimes the meaning of life is to understand, to make meaning, actually. The meaning of life is to make meaning. Sometimes it's that. Sometimes it's to leave the world just slightly a little bit better than it, like the Johnny Appleseed view,
Yeah.
Sometimes the meaning of life is to, like clear the path for my daughter or for my students. It's to, so sometimes it's that. And sometimes it's just, you ever have moments where you're looking at the sky or you're, by the ocean, or sometimes for me, it's even like I'll see, like a weed poking out of a crack in a sidewalk, and you just have this overwhelming sense of the like wonder of the world. Like the world is like just the physical world is so wondrous, and you just get very immersed in the moment, like the sensation of the moment. Sometimes that's the meaning of life. I don't think there's one meaning of life. I think it's a population of instances, just like any other category.
I don't think there's a better way to end it, Lisa. The first time we spoke is, I think, if not then one of, I think it's the first conversation I had that basically launched this podcast. That's actually the first conversation I've had that launched this podcast.
Wow.
And now we get to finally do it the right way. So it's a huge honor to talk to you, that you spend time with me. I can't wait for hopefully the many more books you write. Certainly can't wait to. I already read this book, but I can't wait to listen to it, because, as you said offline, that you're reading it, and I think you have a great voice. You have a great. I don't know what's the nice way to put it, but maybe NPR voice in the best version of what that is. So thanks again for talking today.
Oh, it's my pleasure. Thank you so much for having me back.
Thank you for listening to this conversation with Lisa Feldman Barrett, and thank you to our sponsors, Athletic Greens, which is an all-in-one nutritional drink, Magic Spoon, which is a low-carb, keto-friendly cereal, and Cash App, which is an app for sending money to your friends. Please check out these sponsors in the description to get a discount and to support this podcast. If you enjoy this thing, subscribe on YouTube, review it with 5 stars on Apple Podcasts, follow on Spotify, support on Patreon, or connect with me on Twitter at Lex Friedman. And now, let me leave you with some words from Lisa Feldman Barrett. It takes more than one human brain to create a human mind. Thank you for listening. I hope to see you next time.